What lies beneath the ocean's surface is a mystery unlike any other, a realm of unimaginable power, untamed forces, and secrets we're only beginning to uncover. But this year, something beneath the Earth could awaken. Something capable of reshaping the world as we know it. Hidden miles below the surface, an underwater giant stirs. A colossal volcano with the potential to unleash devastation on a scale humanity has never faced. What if the planet's most silent depths become the loudest threat? How could an eruption beneath the waves ripple across continents, altering ecosystems and even climate itself? The signs are there, the warnings are growing louder, and the question remains, are we prepared for what's coming? Dive into the unknown with us and explore the extraordinary forces lurking where the light never reaches. A ticking time bomb beneath the waves. Off the coast of Oregon, a powerful geological event is quietly developing beneath the ocean's surface. Axial seamount, an active underwater volcano located roughly 480 kilometers from shore, is anticipated to erupt in the future. Predicting volcanic eruptions so far in advance is an exceptional achievement, as most forecasts are made only hours or days beforehand. However, Axial's distinct behavior over recent years has provided scientists with a rare chance to make such a long-term prediction, offering a valuable insight into the future of eruption forecasting. For more than a decade, a sophisticated network of monitoring equipment has tracked every small movement of axial seamount. From its tremors and vibrations to its surface swelling and shifting, this data is collected in real time through a seafloor cable system. This setup makes axial seamount the most extensively studied underwater volcano on the planet. Leading this research is William Chadwick, a geophysicist at Oregon State University, who, along with his team, has dedicated years to understanding this dynamic volcanic hotspot. Recently, specific signals from the volcano have captured their attention, pointing to what could be a significant event on the horizon. Uplifting has been observed in axial surface since November 2022, and it has almost grown to the pre-2015 eruption height. Such uplift activity is a sign that magma is accumulating under the volcano and building up pressure, thus enabling an eruption to probably happen. Long-lived deformation is a similar picture to what was seen before the last eruption in 2015 that Chadwick and his team were able to predict. Current volcanic signs and the recent increased seismicity indicate moving magma, which has encouraged researchers to focus on a possible eruption in the coming years. The uniqueness of forecasting volcanic eruptions this way is magnified by the fact that most volcanoes are forecasted short-term, typically only hours before an eruption. To refine their estimates, a new tool has since been devised by the research team that computes the exact moment magma will break out onto the surface. Artificial intelligence was also employed to sketch out the pattern of earthquakes that occurred before the 2015 eruption, allowing scientists to hone in on early warning signs they need to keep an eye on down the road. It raises the question, will precursory earthquake detection methods work out as they seem? High stakes are for volcanologists. It will redound to their advantage to an unforeseen degree if the AI model holds, since they will then have valuable insights into axial seamount's behavior, and might then send in remotely operated vehicles to view the eruption in real time. Being able to see things happen firsthand would go a long way towards understanding underwater eruptions. Beneath the waves, axial seamount is sending signals, subtle but undeniable. Could these faint warnings hold the key to unlocking nature's next move? Limits of eruption prediction. Although underwater volcanoes are generally less of a direct threat to human life compared to those on land, they can still cause significant harm. The eruption of Hunga Tonga Hunga Hapai is a stark example, as it triggered a massive tsunami that led to widespread destruction, severely impacting both properties and lives. Tsunamis caused by underwater eruptions can create devastating consequences for coastal areas, as the Hunga Tonga disaster demonstrated so vividly. In the case of underwater volcanoes like axial seamount, the risk of false alarms is minimal because of its remote location and the absence of human settlements nearby, reducing the chances of immediate human impact from its activity. The decades of monitoring and data collection that have characterized the eruptions of Axial now allow the possibility of incorporating an understanding of this specific volcano's behavior into the prediction. A volcanic eruption cannot be foretold with the use of a crystal ball. Rather, scientists look for patterns in volcanic activity and seek to apply those patterns to predict future behavior. Axial seamount is where the action is, as scientists would like to test and refine their predictions for eruption times. Technically, every eruption is an occasion for refining these methods, and with Axial's relatively frequent eruptive activity, it is the best possibility to learn how underwater volcanoes work. For the work of volcano research, notwithstanding whether or not Axial erupts in 2025, this prediction is a milestone. It is not meant to change this world of eruption forecasting, but it will give us some insights into volcanic activity as a dynamic and mysterious natural system. In that context, it can help us to prepare for future volcanic eruptions in the Pacific Northwest and elsewhere. Hunga Tonga event. On January 15, 2022, the Hunga Tonga Ha'apai volcano erupted in the South Pacific, unleashing destruction on a massive scale. It became one of the most powerful undersea volcanic events in recent history, leaving a significant impact on both the environment and the lives of those in its path. In the weeks leading up to the disaster, the volcano showed signs of increased activity. A smaller eruption on January 14th triggered a minor tsunami that went largely unnoticed. However, the main eruption the following day was far more explosive, lasting approximately 11 hours. It sent a colossal plume of volcanic ash and gases into the stratosphere, with shock waves echoing across the atmosphere and tsunami waves spreading through oceans worldwide. This eruption became a truly global event. The volcano, located about 65 kilometers northwest of Tonga's main island, Tonga Tapu, became the focal point of one of the most dramatic natural disasters in modern times. Its eruption was rated at a volcanic explosivity index of 5, meaning it was classified as very large. A powerful tsunami was generated almost immediately, striking the islands of Tonga and causing widespread destruction. 4 lives were tragically lost, but the toll could have been much higher. The relatively low number of casualties was credited to the eruption's timing during daylight hours, effective tsunami warnings, and strong public preparedness efforts, all of which helped to minimize the human cost of this catastrophic event. However, property and infrastructure were utterly devastated. Some resorts on the northwestern tip of Tonga Tapu Island were completely razed. Other islands such as Namuka Iki, Mango, and Tonumea were also severely affected, with ocean surges inundating low-lying areas and destroying whole communities. On Mango, not one house was spared as the waters engulfed them. Damage in Tonga reached $118 million, primarily due to the tsunami. Other losses due to the eruption included agricultural damage and damage to a crucial sea-bottom fiber optic cable. But those extreme waves did the most destruction. The human toll was relatively low. However, the emotional and economic tolls were utterly devastating. The world watched in horror as homes, businesses, and livelihoods were shattered, even though they left an indelible scar on Tonga. The global climate impact of underwater eruptions. Underwater volcanoes quietly shape the ocean floor, but their eruptions can have far-reaching effects, extending far beyond the seas to impact the Earth's climate. When a large eruption occurs, it releases vast amounts of gases, such as carbon dioxide, sulfur dioxide, and water vapor into the atmosphere and oceans. These gases, particularly when released in high volumes, can disrupt global climate systems. A striking example is the 2022 eruption of Hunga Tonga Ha'apai, which injected an unprecedented amount of water vapor into the stratosphere. This surge of water vapor trapped additional heat in the atmosphere, disturbing the planet's natural temperature regulation. If a similar eruption were to occur at axial seamount or in the Mariana Trench, the impact on climate patterns could be immense. In addition to gases, volcanic ash from underwater eruptions introduces further complications. These tiny particles, known as aerosols, can block sunlight and cause temporary global cooling. However, the broader consequences for the oceans and atmosphere are harder to predict. Ash clouds can alter the chemistry of surface waters, threatening plankton, the tiny organisms that form the foundation of the marine food web. Disruptions to plankton populations can cascade through the ecosystem, impacting marine life and fisheries. Furthermore, the cooling effect on ocean surfaces can interfere with ocean currents, which are vital for maintaining weather systems and regulating global climates. An eruption in the Pacific, for instance, could trigger a series of changes that might be felt as far away as Europe or South America, highlighting the interconnectedness of Earth's systems. The underwater eruption additionally poses a danger of releasing huge amounts of methane, which is considered a strong greenhouse gas stored on the seafloor as hydrates. The volcanic heat could trigger the destabilization of these deposits, causing sudden and massive methane releases into the ocean and then into the atmosphere. Methane traps a lot of heat in the short term compared to CO2, thereby holding the option of accelerating global warming very quickly. As scientists keep an eye on places like the axial seamount and the Mariana Trench, they remain acutely aware of how these geological events could precipitate or exacerbate the already fragile climate crisis of the Earth. Finally, if all goes well, the carbon sink would act as its counterpart to the oceans. The volcanic action interferes with the delicate balance of ocean chemistry and is detrimental to tiny phytoplankton, which absorb carbon dioxide from the atmosphere. An unexpected atmospheric rise of carbon dioxide and subsequent enhancement of climate change would occur in the absence of these carbon sequestering processes. As underwater volcanoes keep awakening, their unseen might underscores the interconnectedness of Earth's systems and urges the necessity of fully understanding their impacts on the planet. The impact of underwater eruptions doesn't end with the seas. It echoes across continents. What happens when the world is forced to listen? Global wake-up call for undersea volcanoes. What made this eruption truly remarkable was its ability to cause effects far beyond the local area. Along with the tsunami that devastated nearby regions, the eruption generated an atmospheric pressure wave that traveled around the entire planet. Tsunami waves were recorded on distant shores, reaching places like the Pacific coast of the United States and even as far as South America. This widespread impact revealed the vast reach of undersea volcanic eruptions and underscored how deeply connected Earth's systems are, with events in one region capable of influencing environments across the globe. It was a tragedy and a learning occasion in that regard. With the transient eruption of Hunga Tonga Hunga Ha'apai, it is a reminder of the hidden dangers lurking quietly beneath the surface of the ocean, volcanoes capable of unleashing destruction. But the other picture painted is one of resilient communities and the deployment of modern technology. Research is now focusing on volcanic tsunamis, which are lessons derived from this eruption to improve preparation for similar events worldwide. Hunga Tonga Hunga Ha'apai's influence extended very much beyond the South Pacific and into the realm of science. Scientists are looking into the event as a prelude for activities occurring in the Mariana Trench, where similar volcanic forces lie beneath the surface. Another question that lingers around the area of eruptions is, will Mariana Trench geological activity soon make itself felt in ways we've ceased to ignore? Mariana Trench. Mystery. From above, the Earth's surface can seem relatively smooth, with its rolling plains, towering mountains, and vast oceans. But beneath that surface lies a far more dramatic and intricate world. Just as there are peaks and valleys on land, the ocean has its own geological marvels. Among the most mysterious and awe-inspiring of these is the Mariana Trench. Located in the western Pacific Ocean, the Mariana Trench is not only the deepest oceanic trench on Earth, but also one of the most enigmatic. Spanning over 1,580 miles, this trench is much more than just a deep groove in the ocean floor. It offers a window into the geological history of our planet. Its depth and structure provide clues about the powerful forces that have shaped the Earth over millions of years. At its southern end lies Challenger Deep, the deepest point known on the planet. With a depth exceeding 36,000 feet, it is a realm of perpetual darkness, where the pressure is so immense it could crush a submarine in an instant. To visualize this depth, consider that Challenger Deep is nearly 3 times the height of Mount Everest. Even if Everest were placed at the trench's bottom, its summit would still be submerged under miles of water. It's a place so extreme that it challenges our understanding of what is possible on Earth. What makes the Mariana Trench and Challenger Deep even more captivating isn't just their astonishing depth. It's what happens beneath their surface. The trench lies at a critical junction of Earth's tectonic plates, where the massive Pacific plate is being forced under the smaller Mariana plate. This ongoing collision generates intense geological activity, making the trench a hotspot for scientific discovery. Within this hostile environment lie secrets that could unlock new knowledge about the Earth's inner workings, hidden in the crushing darkness of one of the planet's most extreme places. The Mariana Trench hides more than just geological and biological treasures. There, recent investigations have found newer and more pressing geological inquiries. In December 2024, scientists tracking seismic activity in the Pacific Northwest, offshore Oregon, allegedly made a startling prediction. They project that an underwater volcano near the trench is poised to erupt in the future. Though this eruption will be calm under the ocean, it might ripple on perturbed marine ecosystems nearby and afterward affect climate. Such a prediction, however, is nothing out of the ordinary for the scientists. Eruptions of this order of magnitude seldom happen, and even if they were to happen, the monitoring becomes several times more difficult as they are occluded underwater. The increased unrest in this region has made scientists predict an eruption of great magnitude from axial seamount sometime in the future. The anticipation of such an eruption has many human beings interested, fully aware that recoveries from oceans are a continuing process that the people agree to pay close attention to. What would the eruption mean for the ecosystems around? Will it perhaps change the course of history in ways we cannot appreciate yet? One thing stands sure. The eruption of yet another Pacific Northwest submarine volcano will constitute an everlasting event in the eyes of geologists, ecologists, and the entire world. A hotbed of hidden threat. Situated just to the east of the Mariana Islands in the western Pacific Ocean, the Mariana Trench is a treasure trove for geologists. This region is shaped by both intense geological activity and an incredible variety of life. What makes the trench so significant is its position within a tectonic subduction zone. Here, the Pacific Plate, a section of the Earth's crust, is slowly being pushed beneath the Philippine Sea Plate. This ongoing collision between the plates is key to the trench's creation and the geological activity that continues to transform the area. As one plate dives beneath the other, immense pressure and heat are generated, making this trench a crucial location for studying how the Earth's interior works. However, the Mariana Trench isn't just a static feature of the ocean floor. It's an active, ever-changing zone where remarkable geological processes are continuously uncovered. Some of the most groundbreaking discoveries about volcanic activity have emerged from this region. In December 2015, researchers made a fascinating discovery near Challenger Deep: undersea mud volcanoes and hydrothermal vents. These findings suggest that the volcanic activity in this part of the trench is much more dynamic than previously understood. The mud volcanoes, which release plumes of mud and gases, are created by complex geothermal processes happening deep within the Earth's crust, offering scientists a rare glimpse into the hidden forces shaping our planet. The hydrothermal vents, by discharging hot, mineral-rich fluids into the surrounding waters, signify volcanic activity while creating an ecosystem entirely on their own. The vents allow for the existence of strange and exotic species, organisms that thrive under conditions most life forms would never endure, such as extreme pressure, heat, and total darkness. Representing a seminal hour in our understanding of the volcanism of the trench, the appearance of hydrothermal vents places even stronger evidence of active volcanism in the trench beneath. The voicing of long-suspected intrusive volcanic processes prone to the tectonic activities of the trench was sealed with the 2015 evidence. Hydrothermal vents are undoubtedly one of the strongest pieces of evidence, indicating that beneath the trench itself, geological processes are in all likelihood heavily active. Around the Challenger Deep region, these features appear to be concentrated, giving credence to the notion that geothermal activity is dense here, and that the floor of the Earth may be undergoing tensile stress, compressive stress, and transformations. In multiple ways, these mud volcanoes and hydrothermal vents play their parts. Providing a realm for observation became an outdoor laboratory for scientists studying the ins and outs of sub-oceanic volcanic processes. Beyond this, they further offer insight into the dynamics of the trench. The Mariana Trench is not a wide and stagnant structure, but a highly unstable and dynamic environment where geological forces work in perpetuity. This dynamism is synchronous with the eruption of volcanoes in the Mariana back arc, i.e., to the west of Challenger Deep. This back arc zone, characterized by seafloor spreading, along with frequent volcanic eruptions, plays a crucial role in the region's geological landscape. Unveiling the depths. The discoveries made in the Mariana Trench hold incredible significance, as this trench is far more than just a deep scar in the ocean floor. It is a dynamic and ever-changing part of the Earth system, constantly shifting and evolving. With the advancement of technology, scientists are uncovering more of the secrets hidden in this dark and remote part of the world. A major breakthrough occurred in 2015 when researchers, using an autonomous underwater vehicle, captured images of a pristine lava flow. This flow was the result of an underwater eruption that had taken place between 2013 and 2015. What made this discovery so remarkable was not just the location of the eruption, but its extraordinary depth. Over 4 miles below the surface of the ocean, the lava flow, still dark and glassy, showed clear signs of being freshly formed, confirming that the eruption had happened recently. This finding provided a rare opportunity to study volcanic activity at such extreme depths, and underscored the dynamic nature of the processes occurring in the Mariana back arc region. The eruption was dramatically characterized by the culmination of the venting of hydrothermal fluids, somewhat indicating that profound geothermal activity was still present in the region. The findings were remarkable for many reasons. For one, it is very difficult to detect volcanic activity at that depth. Submarine eruptions tend to be rather cryptic. They don't show the same surface telltales as eruptions on land. Furthermore, these earthquakes are generally overlooked since the more subtle ones occur along with the volcanic eruptions. Due to the progress made in technology, like unmanned vehicles and remotely operated systems, geoscientists have sometimes been able to track these eruptions more reliably. After the eruption, the region underwent drastic changes. The hydrothermal system remained active for several years after the eruption, gradually cooling down, and the lava flows started being colonized by a new ecosystem. Such a scenario is referred to as primary succession, whereby new organisms begin to establish and thrive in an environment that has just been subjected to a major disturbance. At the time scientists returned to the site in 2016, venting in the system had already begun to relax considerably, but it still offered rare opportunities to observe biological adaptation and recovery in the wake of such an event. The Mariana Trench and its surrounding area are not just another geological oddity. They ultimately stand as a monument to the vastness of power and intricacies of Earth's volcanic forces, exploring the deepest eruptions. The crushing pressure and total darkness of the Mariana Trench hide volcanic systems capable of triggering events with worldwide consequences. These hidden forces are a powerful reminder of how unpredictable and potentially destructive underwater volcanoes can be. Far below the surface, volcanoes like those in the Mariana Trench silently reshape ecosystems and alter ocean currents, impacting the planet in ways that scientists are only beginning to uncover. The recent prediction of volcanic activity at axial seamount, located off the coast of Oregon, serves as another reminder of how little control we have over these forces. Axial seamount, an active volcanic hotspot, has eruptions that may not make headlines like land-based volcanoes, but their impact can be just as significant. These eruptions have the ability to disrupt marine ecosystems and set off chain reactions with effects that extend far beyond the immediate area, reminding us of the hidden power beneath the waves. Predicting the emergence of these underwater volcanoes months or years ahead is a revelation, increasing the seriousness and relevance of global monitoring systems for underwater volcanic activity. Such monitoring systems will provide data of utmost importance for risk reduction, protection of coastal communities, and minimization of impending loss. The unpredictable nature of these underwater volcanoes stands in the way. Past volcanic eruptions, such as that of the Hunga Tonga Hunga eruption, are telling signs that underwater volcanic events have global consequences. Though distant, it sent shockwaves ringing through the atmosphere and created tsunami waves across the Pacific Ocean, thereby wreaking havoc elsewhere far from the source. These have shown us how much we have yet to learn about such deep-sea volcanoes. The future of exploration in the Mariana Trench and similar volcanic territories opens up new avenues. Bravely so, with technological advancement with tools such as autonomous underwater vehicles and remote sensing far redefined deep ocean floor exploration. Currently, these very instruments allow scientists to acquire real-time data from untraversed depths, giving unparalleled insight into underwater volcanic systems. Autonomously operated AUVs have now successfully penetrated the extreme depths of the trench and have started gathering important data regarding volcanic activity, hydrothermal vents, and mud volcanoes living in the least friendly environment on Earth. How it holds the key to Earth's secrets. The study of underwater volcanic systems is about much more than geology. Near these volcanoes, hydrothermal vents on the ocean floor host extraordinary ecosystems, teeming with life forms that thrive without sunlight. These organisms reveal how life can adapt to extreme environments and may even hold clues to how life began on Earth. By studying how volcanic activity impacts these unique ecosystems, researchers gain a better understanding of the broader environmental effects of underwater eruptions and their influence on the planet. Exploring these deep-sea volcanoes also has important implications for people and communities. As global populations grow and coastal regions become increasingly vulnerable to natural disasters, it becomes critical to understand the risks posed by underwater volcanoes. With improved forecasting techniques, scientists can provide early warnings that may save lives and reduce damage to critical infrastructure. However, accurately predicting volcanic eruptions, especially those beneath the ocean, remains a challenge. It requires identifying patterns from previous events, yet every volcano behaves in its own unique way. Despite these difficulties, ongoing research into volcanic systems like axial seamount offers significant opportunities to improve prediction models and deepen our knowledge. Axial's frequent eruptions make it an ideal location for scientists to test new theories and methods. Each eruption provides valuable data, helping researchers refine their tools and better understand the unpredictable nature of these powerful underwater forces. This work not only advances science, but also strengthens our ability to prepare for and respond to the potential dangers of these hidden giants. Looking into the future, exploration of the Mariana Trench and other similar underwater volcanic regions will not only turn to knowledge, but will act as preparation. Underneath Earth's volcanic systems evolve, so too does our capacity for monitoring, predicting, and understanding. There still exists such a great likelihood for discoveries regarding deep ocean volcanic activity and the ecosystems existing thereon. The more we learn of these submerged giants, the more equipped we will be to protect the planet and those living on its shores. The next eruption, as foretold, may be the key to understanding the dynamics of our planet even more. As we mull over the rising threat beneath the deepest point of the Pacific waters, one last question arises. Are we prepared for a catastrophe that may sweep clean every vestige in its way? Can we avert it, or will it be too late? The secrets of the ocean hold answers, but they also carry warnings. Are we prepared to face the forces waiting to rise from the depths? Facing the power beneath. As we continue to explore and expand our understanding of the planet, one thing becomes increasingly evident. Humanity must prepare for the immense power lurking beneath the oceans. Underwater volcanoes, once thought to be distant and unrelated to daily life, are proving to be forces of change, capable of altering ecosystems, influencing climates, and even impacting human societies. The question is not if these forces will reveal their power, but when. Whether it's the anticipated eruption of axial seamount or the enigmatic activity within the Mariana Trench, the need to study and monitor these natural phenomena has never been more critical. Technological advancements have given us the tools to delve deeper into the ocean's secrets, providing new ways to track, predict, and potentially reduce the effects of underwater eruptions. Innovations such as real-time data transmission, AI-driven analysis, and remotely operated vehicles are transforming how we study the ocean floor. These tools allow scientists to not only unravel the processes behind these eruptions, but also prepare for their far-reaching consequences. Although early warning systems for submarine eruptions are still in their early stages, they hold the potential to one day protect coastal communities from destructive tsunamis and other environmental disasters. But preparation involves more than technology. There is a need for a concerted international effort to address underwater volcanoes and their obvious ramifications for climate and ecosystems. Governments, scientists, and organizations must collaborate to improve monitoring networks and develop effective disaster response strategies. Public education and awareness are critical to prepare communities in imminent danger to react appropriately when the ocean goes wild. In our exploration of the unknown, the forces beneath the waves remind us of the immense power of our planet, forces that urge us to remain humble, respect the natural systems that sustain our being, and realize that no matter how advanced we think we may be, there is still much that we do not understand. The next major eruption may bring devastation, but on another level or dimension, it will bring discoveries about our planet and the delicate balance that enables life to survive on the surface. The greatest question comes against these hidden giants. Can we prepare for the inevitable, or will we just have to adapt when the moment comes? If you found this video eye-opening, don't forget to like, comment, and share your thoughts below. Make sure to subscribe and hit the notification bell so you never miss an update on this ongoing threat. And for more fascinating content, check out the next video on the screen. Trust me, you won't want to miss it. Stay informed and safe.